Welcome to this episode of DIY3DTech.com. In this episode, I want to share this new slicer I've come across, IceSL. So for the longest time, about 3 years, I've been a real big Cura fan, but of lately, the newer versions of Cura to me actually have been a bit disappointing. And I know that there's also paid applications out there like Simplify 3D and things like that. I understand that they're great programs and that, but most of the people that watch this channel, typically are on a budget or this is a hobby, and dropping $150 for simplified 3D, well, justifiable in some sense. Not everybody can do it. So I really like to stick with more of the open source freeware stuff, as there's a lot of other people covering Simplify 3D. So with that, I ran across, or I should say went looking for a new solution, and I ran across IceSL. And I'm really excited because there's actually a number of different components to IceSL. So there's the Forge component, which is the slicer combined with a Luna-based interpreter. Luna is a programming language that allows you to do OpenSCAD stuff and then directly slice it, which I think is really interesting and something I'm going to look into. I've done some Luna programming in the past, and for those that have followed the channel for a while, I also have the OpenSCAD channel. I've been a programmer professionally for many years, and again, I really love programming, so I'm very excited about this piece. The piece, though, that we're going to focus on today is just the slicer component, IceSL-slicer. But there's also a web version I want to touch on real briefly, and I have it pulled up over here in the web browser. So you can get this full functionality in a web browser, or at least parts of it. I shouldn't say full functionality. And so you have the interface. I've got the part which we're going to be working on in the desktop or client version a little bit later, but just so you can see it. The other interesting thing is you can point it to a URL to slice. So you can have your different STL files in an HTTP repository and send them here to be sliced. So again, a lot of cool functionality here. But I want to go back to the slicer and talk about this for a minute. So what I want to do is I want to scroll down, and what I want to talk about is some of the key features. And one of the ones that got me really excited for a freeware program, basically, at least for personal use, is per layer settings. This is really cool, folks. So you can set on a per layer basis your printing attributes. So this is really kind of crazy to me for a free program. So you see something like this in Simplified 3D, which you need to drop $150 for. And so I'm excited about it because this is something I've wanted to experiment with for a while. And one of my longtime viewers, Dr. Dave, had actually sent me something. And if you look in the way back past, I looked at a couple other slicers probably a year or two ago that did this, but they weren't very good at doing this. And so I kind of let those go. But I think it's something interesting to come back to. The other piece is not only can you do per layer, but it has an optimal adaptive slicing algorithm to it. So it's basically smart. You tell it, and I'll show you this in action. You give it an STL, you tell it to calculate, and boom, it optimizes the layers for the structure of the object. I think it's really cool. How good it is, I don't know yet. We're going to find out. We're going to experiment with this. But again, in this video, it's going to be more so just kind of taking a look at it. We are going to print a piece out and see how it works. But I'm not going to get into too great a depth. I just want to share with you guys this find. So maybe we can work on this together. The other thing I really like about this is the infill types, the hierarchical infills as well as progressive infills. This is just really too cool because one of the things I think with 3D printing, it really is all in the math of the slicer. The 3D printer itself is a rather basic machine, and it's really the math in the slicer that does the heavy lifting. And some of the stuff I've seen with this really excite me in what we can potentially be able to do with 3D printing. And this actually goes beyond 3D printing. I got to share with you guys. It also goes into CNC and laser cutting. So really excited. I'll cover those pieces in a little bit. The other piece I like is this adaptive bridging. This is really cool because I've long thought that supports haven't gotten enough attention. in the 3D printing community. And again, so these guys are really starting to look at this stuff mathematically. And so again, more excitement there. The other piece that I like about this is they seem to treat the extruders as brushes, which I really think is an interesting metaphor, not only from a standpoint of being a metaphor, but how you look at the extruder is think about it as basically a brush on a canvas, and how you can treat it, and how you can apply different functions to it as if it were. So again, we have implicit surfaces, we have offsets, which are all kind of cool things. We have tight ooze shields for maximal supporting structures. Also for dual extruders, I think the clean color algorithm. So the way it handles dual extruders, I do have a dual extruder machine, and quite frankly, I have not found really good dual extruder software, again, out there in the freeware market for this, so I'm really excited to give this a try. So we're going to explore this. So again, and then also as I talked about the Luna scripting language and just tons of other stuff. We'll get into more of that. Now, there's a couple catches with this. This isn't all Nirvana. Number one, it only comes in a Windows and a Linux version. Sorry, no Mac. Unless you run it in a virtual machine or something like that, and I would highly recommend it. The other piece too is it runs on, it needs basically a GPU accelerator or OpenGL for this to run. So on my Ultrabook laptop and things like that, this will not run because it does not have a compatible graphical interface, and it fails because it is running some sort of CLI type environment in the background. And again, free for non-commercial use, as I mentioned. So, I mean, how better can that get? So, what I want to do is I'm going to pull up the application now. So, let's open up the application. So, I've got this same part. Actually, I have this part printing right now. And so, we pulled it in rather clean, minimalistic interface till you scroll over here. And then it's like, wow. So up here, we can choose the printer type. Now, as you can see here, you can go into with a text editor and edit this. So there's still a little bit of high-endness or command line CLI type stuff that goes along with this. And being a programmer, I think that's pretty cool. I don't think this is for everyone, but what you can do, as you see here for this, I just, for a Prusa style printer, I just picked this and set the individual parameters to that printer. So I'm going to put all my over half dozen printers in here as specific models like I had in Cura, but I'll do that through a text editor. But here's the other piece that I was mentioning that I'm really geeked about. So some of the stuff I have no clue, but what I do have clues about is you can slice to an SVG file. So you can take the slices and you can export it. So say this has 100 and some slices, you could export those slices to SVG files. And then you could bring them into a laser cutter or CNC program and cut those parts out. So I think this really is interesting because, again, there's a lot of times I have an STL file and I have to do some natural acts to convert it into an SVG file, and being able to take one layer out of an entire stack and create an SVG file to either laser cut or CNC, I think is just really, really cool. So I'm looking forward to that. Again, it does meshes, contouring for laser cutting. Again, I'm assuming if you have a pulse width laser. So a lot of cool stuff that you can do. So we're just going to focus on the G code right now. So as you can see, there's under the advanced is where all this stuff is. And so you have the typical model information, orientation and scale information, and then advanced, boom, you hit this up. Now, these things with the little lines, this means you can edit all these things per layer. So you can change your per layer height, you can change your print speed per layer, all the way down. So anywhere you see this, so extrusion temperature, so I can print the bottom at a higher temperature than I print the top, or vice versa. So again, this is pretty exciting. So what I'm going to do is I'm going to hit this up here. And one of the things, since I've already done this, I've already optimized this. So I'm going to discard this optimization and then come back here and then click this layer thickness. So as you see here, I can set this key to anywhere I want, and I can set a second key, so I have two keys, so I can define between these two parameters and my settings. So between here and here and here will be different print actions. Now, these are what I'm guessing at manually. Say I don't want to guess though. I want to optimize this. I just click the optimize button and boom, you can see it does a heat map and automatically optimizes it. Now I can choose to smooth this, or I can choose it to be optimal. And you can see my different print heights here to all the way up to 0.3. And then as I slide it through, I can move this, and you can kind of see how it looks as I move through it. So this is, again, really exciting to me. And again, I can, you can see it's now switched back over to editing mode and things I want to edit. So I'm going to discard this again. Again, go back up over here, and again, so now I can set with these manually, for example, my print speed. So for each one of these, and so I can change my shells, I can change my infill percentages as I go up. So I can start the bottom, say at 25, I can end at the top at 10. So again, I'm really excited about this. So one of the things that I have done is I've taken this object, and one of the things I forgot to mention before I go there is as you kind of cursor over it, you can see the values of this as you cursor over. So since I've cleared the optimization, it's not showing it to me any longer. So one of the things I've done is I've optimized this, and I've sent it to my DaVinci 2.0 to print in ABS in an optimized fashion. So as you saw in the last version, if I go here and do this again, basically all I did is I hit optimize, and this is my optimized model. And sorry, I'm coming down with a little bit of pneumonia, but I wanted to share this with you guys. So anyways, so I've optimized this, and I've sent this for slicing to the printer. So tell you what, I've shared this with you. I'll have the links to all this below. So if you're interested in this, you can go get it. I think it's pretty cool. And then I'll tell you what, let's head over back to the bench, and we'll take a look at the finished product of this collar having been printed out. Okay, welcome back. So we printed this out, and it's rather interesting. So I'm going to try to zoom in on this, and I'm not sure how this is going to come out, but the vertical layering here is pretty impressive on how it did this, and it really is very, very smooth, far smoother than I would get out of Cura. Now, the one thing I have noticed, though, is in my shell selection now, I think this is more my problem than the slicer, is I don't think I gave it enough shells. I told it too, thinking, because I'm not sure how this exactly rates the layering. So I told it 2. It wanted to go 6. And I think this is where part of the problem, where you see here these gaps, where it didn't put down enough of a first layer, nor did it put enough of a top layer here. But again, when it optimized, it said 6, and usually I put 2. So in other words, with the 0.3 layer height, and I think this is more and more I think about it now, talking this through, is where my problem came in, is I think this picked up my override in the layer height when it optimized and put too thin of a coating, because the way it started out down here is actually thin, and it got thicker as it went up. And so I think this was the problem. So I'm going to have to take a look at that. And I think that's probably something worth taking note of. I should probably not change that setting, because I typically, at a 0.3 layer height, use 2 shells. So that's 0.6 millimeters or 2 passes. And so when I set it, I thought that's what it would come out to be. But I think at the lower setting, or at the optimized setting, I should say, it had a lower threshold down here than it did up here from the way it looks. And so I think what happened is my resulting top layer was also thinner than I would have expected. So I'm going to play around with this a little bit more, but so far I've been very impressed with this, and I got to say, this is the first print I've done, so I've kind of expected a few bobbles with this. So, but again, the smoothness, I'm not sure this is coming out. I'm trying to roll this under the light, and I'll try to zoom in on it, but I'm very impressed with this. So anyways, I'm looking forward to playing with this. I'm going to do a few more episodes of this as I go through and learn different things. I'll share them with you guys. I really haven't seen a lot on the internet regarding this. So I don't know how popular this program is or not, but I'm pretty excited by it just by the optimization standpoint, and then also being able to do the Luna coding. It's been a while since I've programmed in Luna, so I'm kind of looking forward to experimenting with it. Love OpenSCAD, so this is sort of just another genre. So hopefully you found this interesting. If you did, hey, give it a thumbs up. Don't forget, Swag Shop's going to be up over there. Subscribe button's going to be over there. And hey, we'll see you guys in the next video. Cheers.
Please click like below and subscribe to the channel to keep up to date on